I'm going to work out the third worksheet in chapter 1, which is the structure worksheet. There are 3 types of questions, and I'm not going to do all the problems because the key is posted. However, a few problems are solved here. The first question is asking, can you convert the condensed formulas to line bond structures? So the formula is given to you. These are called as condensed formulas, where the carbon and hydrogens are shown but not the bonding. So we have to show it in the form of line bond structures. So the way we can draw this is have the carbons with the respective number of hydrogen atoms. Then this is connected to the second carbon having 2 hydrogens. The third carbon, which has 1 hydrogen, and the group in parentheses is a branch. So you will put the branches here. In this video, we are going to solve some problems from the last worksheet on chapter 1, which is the structure worksheet. Most of the problems are pretty similar, so I will work out a few problems and then you can try out the rest of it and check the answer through the answer key. So the first question is asking you, how can you convert the following formulas, condensed formulas, to line bond structures? So in line bond structures, we have to show the bonds in the form of lines connected to the atoms. So in this case, we have carbon connected to 3 hydrogen atoms, the second carbon connected to 2 hydrogen atoms, the third to 1, and then we have a parenthesis with CH3. Whenever we have parentheses, it means that there is a branch at that carbon atom. And then the last carbon atom again has 3 hydrogen atoms. So the way we will draw this is by showing bonds to hydrogen atoms. So this will be the first carbon, the second carbon with 2 hydrogen atoms, the third with 1, but then remember we have a branch here, so that branch is again a CH3, so you connect the 3 hydrogen atoms to that carbon, and then the fourth carbon has 3 hydrogen atoms. So this completes the line bond structure of the first example. Second is again very similar, but here in the second carbon atom you see there are 2 CH3s as branches. So the way we will draw here is again take the first carbon atom, put the 3 hydrogen atoms on it, connect the second one, which has now 2 branches. We need to show every bond as a line. So we have CH3, and then another CH3, then finally a carbon with 2 hydrogen atoms, which is connected to another carbon with 3 hydrogen atoms. Okay, so if it helps, I can put a color onto the carbon atom which has a branch, so you can track it. Again here, this is the carbon atom which has the branch, so that's the carbon atom. Okay. All right, then the next example I picked was E, where you begin with parentheses, which means that the carbon atom, again I would color that, this carbon atom has 2 CH3s attached to it. Okay, so we have a carbon atom which has 2 CH3s, but again since this is a line bond structure, you have to show all the hydrogens attached to the carbon with a line bond. So the carbon which was highlighted in blue, that's the one which has got 2 CH3 branches. Now we move on to the next carbon which has 2 hydrogen atoms. Then we are also missing 1 hydrogen here to the blue carbon, right? So go ahead and draw that one, and then we have continuing this with 2 CH3s attached to this carbon atom. Maybe we can put a different color to that, so let me highlight that with the red color. So again, this one has 2 CH3s here. Every carbon hydrogen bond needs to be shown as a line. and then finally we have a CH2 and a CH3. So a way by which you can convert condensed formulas to line bond. Okay, usually it's organic chemistry books do not use these line bond structures when we have larger structures because it becomes very crowded. So either it is a condensed formula, or we sometimes use what is called as a skeletal structure, and that is what we are going to see in this next example. So here again we have a condensed formula. Now we have to convert that into a skeletal structure. Now what do we mean by skeletal structure is where it's just lines where each point on the line represents a carbon atom. Hydrogens are not shown, and we assume that every carbon atom's valency is fulfilled either through bonding with a neighboring carbon atom or through hydrogen atoms. Okay, so here the best way to do this is count how many carbons you have. So you have 1, 2, 3, 4, 5. So you draw a zigzag structure, and every point of the chain is a carbon atom. So if you start with this carbon atom, that is the one that's shown in blue. Then if we have the next one as the red, this is the second carbon atom. Again, alternate that with the blue, which will be the next blue here. Alternate that with the red, that's this one. And then finally we have the fifth carbon atom, which is this one. Okay, so that's a skeletal structure of this. We do not have to show any of the hydrogen atoms because we assume that these carbons' valencies are fulfilled by hydrogens or by bonding to the neighboring carbon atom. So for example, this first carbon atom here, it has 3 hydrogen atoms, which we do not have to show. So that's 3 bonds plus one of them is connected to the neighboring carbon atom. Okay, let's try this one. Here we have a carbon which is connected to 2 CH3s, right? So the way we will do it is, let's just use the black color. Okay, so we will start like this: 1, 2, 3, 4, and 5. So one of the CH3s is this one. The second is this one. Okay, so if I highlight this carbon atom, that is my carbon atom, this one. Okay, so it is connected to one of the CH3s, but then we have 2 of them here, right? So I'll go ahead and put one more. Here's the black pen here. So the second carbon atom, second CH3 group is here. This shows me that the red carbon atom has 2 CH3s attached, which is what it's shown here. Then we have a CH2, then another CH2, and a CH3. Oh, actually I have an extra here. Okay, so we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and on the second carbon atom here, we have another branch here. Okay, and then now look at the third one, which I picked is the F example. So you see we have CH3, CH2. So the way we will draw it is 1, 2, right? So that's my CH3, CH2 attached to a carbon atom, then a CH2, another CH2, CH, which is connected to a CH3. It's the branch, another CH, CH2, CH2, and CH3. So a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what we have. See, 1, 2, 3, 4, 5, 6. Then we have 7, 8, 9, and 10. Okay, but we are not done yet. See, let's again highlight the carbon atom which has got branches. At the carbon atom which is shown as the red color, that's this carbon atom here. Okay, so see we have a CH3, CH2 attached, and now we have one more CH2, CH3 attached. So you have to go ahead and draw that one. Also, on the last carbon atom, which we can highlight as blue, okay, this one, it has got a CH2, CH2, CH3. So that's my carbon atom, which has got a CH2, CH2, CH3 attached, but there are two of them. So you have to go ahead and draw the second branch also. Okay, so this completes my structure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my chain here, and then I have a CH3, CH2 branching out, another CH3 branching out, and then we have CH2, CH2, CH3 branching out. Okay, so that's the question number 2. Then another type of question that's asked is how to convert skeletal structures to condensed formulas. Here skeletal structures are given, and then you have to change them into condensed formulas. So the way we will do it is here we have CH3, correct? This is CH3. This one is a CH2. This one is a carbon connected to a CH3 as a branch. So you can, but there is also a hydrogen here, right? You will put CH and then it's CH3. Same thing, we have a CH with a CH3 and then CH2, CH3. Okay, if it helps, I can highlight the branched carbon atoms. So these are the two branches, right? So here is my branched carbon atom, and then the next branch is this one. So that's how A is written. It's, B has two CH3s attached to one carbon atom here, so I will go ahead and put CH3, 2. Okay. Again, if you highlight that carbon atom, that's my red carbon here, which is now connected to a CH2, another CH2, and then we have a C connected to C, 1, 2, 3 CH3s, right? So the way we will put it is put all the 3 CH3s in parentheses, the 3 is a subscript. If you again want to highlight the carbon atom which has got the branch, this is the carbon atom. So that's my carbon atom which has got 3 CH3s as the branches. The last one, which I took as an example, is C. Here again, if you look at this carbon atom, has 2 CH3s, and then connected to one I think I forgot in section B, put a CH, right? Remember, we have to make sure that the hydrogen is also written. So here we have a CH3 twice, CH, again, and then we have a CH2, another carbon atom with a CH3 branch, another carbon atom with a CH2, CH3, correct? And then we have CH2, CH2 with CH3. Okay. So again, I would highlight the carbon atoms which have got the branches. So that's my red carbon atom. That's this one. Then we have the carbon that has a branch as a CH3. That's my blue carbon atom. Then right next to it, we have this carbon, which has got a CH2, CH3 branch. That's my carbon atom here. And then we have CH2, CH2, CH3. So I hope you understood how to draw different structures, skeletal structures, or line bond or condensed formulas. Okay, practice with the rest of the examples, and we'll work out some more problems for the chapter 2 in the next video.